Lesson 2 today. All right, the big thing with lesson 2 is that for some of you it makes a lot of sense. For some of you it really isn't necessary. So, what it's talking about is decomposing, which is always a good strategy. But it's not always necessary. So, if you're looking at number 1, it says a rectangle that is 10 units long and 6 wide. Now, probably all of you, if we were to solve this for the area, would say 10 times 6, and you could count by 10 6 times, and you would get 60. Now, if it wasn't such a friendly number like 10, then decomposing makes perfect sense. You know, like 6 times 13 isn't easy, but 6 times 10 and 6 times 3 are. So this example isn't my favorite, but we will actually do it. So it says find 2 different ways to solve this. So what it's saying is take this side that's 10 and break it apart into 2 more doable. So 10 is pretty doable. That's part I have a hard time with. So if you were to say, well, I like counting by 5s. So I can do 2 different squares of 6 times 5, which is 30, and 6 times 5, which is 30, and 30 and 30 is 60. So you'd still get to that same answer, but it might be a little bit more doable. So 6 and 10 still. Now if we were to take this 10 and decompose it different now, this is the part where it gets kind of tricky, because I think, well, if we were to do it as an 8 or a 7, like those aren't the friendliest of numbers, but let's say we do like a 6 and a 4, because 6 and 4 is 10. So 6 times 6 is 36. 6 times 4 is 24. So 36 plus 24 is 60 as well. So the area, no matter how we decompose it, the area is always going to stay the same. There's 60 square units on the inside. Now, like I said, this makes more sense when you get into bigger ones. Like if we were to do 6 times 16, that's not mental math anymore for most of us. But 6 times 10 is doable, and 6 times 6 is doable. So you'd have 60 plus 36, and we could come up with 96 pretty easy. All right, next page. So this one, they're breaking it apart for us. So really what it's saying is, here is a rectangle that is 4 wide, that's right here, and 5, 6, 7, 8 long. Now, for some of you, 8 times 4 is a pretty easy basic fact. 8, 16, 24, 32. So this would be 32 square units. Now, if you're decomposing, you would do 2 smaller problems. So you'd have the 4 times 3 is 12. And then you'd have 4 times 5 is 20. And 20 plus 12 is 32. So it's breaking it apart. Now down here, you'd have to draw the rectangle. So these get to be a little bit tricky. So if you kind of look at what's going on here, you have a 3 by 8, which is very much like this one. So you'd have 3, and then you're dividing this one into a 5 and a 3, or a 3 by 8. Something like that. So 3 times 3 is 9, 3 times 5 is 15, 15 and 9 is 24. So a little bit trickier. So this one I would do 4, because my 4 is consistent. So and then I have a 5 and a 3, which is an 8. So a 4 by 8, a 4 by 5, and a 4 by 10 for my squares, or rectangles, sorry. Change it into a 6. Sorry. All right, so the next page, now we have unknown sides. So this is all fact family kind of stuff. So if you look at number 1, 8 times something equals 72. So you have to figure out what that something is. So you could either skip count by 8s till you get to 72. Do when you know, remember 8 times 5 is 40, and then you could count up from there. A lot of kids know 8 times 8 is 64. You could count up from there. So you're thinking, what times 8 is 72? Or you could do 72 divided by 8, a little trickier. So this one too, if you count by 12s, I mean, you could even use addition. 12, 24, plus 12 is 36. Oh, this one's talking perimeter. So the perimeter is the distance around. So if you know that this side is 12, this side is also 12. So that's 24. And then you have to think of, well, what other two sides would get me there. So if you had it as, let's say, a 5 and a 5, so that'd be 24 plus 10, that's 34, not quite there. So if we change this to a 6 and a 6, so then it's 12 plus 24, 36, nope. So change it into a 7 and a 7. So then it's, because we know that this is 12, so 12 and 12 is always 24. So then if we had this, I'll change it to a blue. So a 7 and a 7. So we'd have 24 plus 14. 4 and 4 is 8, 38. So that would be it. So the missing side would be 7 centimeters. Because 7 and 7 is 14, 12 and 12 is 24, 14 and 24 is 38. So that's the distance around. So this one, another perimeter one, I peeked ahead. So if this side is 24, this side is also 24. So what I know is that I have 48, because 24 plus 24 is 48. So I have to figure out this. So these two sides for perimeter. So now these two sides added to 48 are going to be 64. So if I did something easy, like a 5 and a 5 is a 10, that'd be 58. A 10 and a 10 is 20. So 48, 58, 68, that's too much. So I know it's in between a 5 and a 10. And I can just play with those numbers until it actually fits. So area is a multiplication equation. 7 times something is 56. Perimeter is a little bit different. More of an addition equation. Alright, so this one, it's just putting the same kinds of problems into word problems. So if you have 7 rows of tiles, and you're using 42 tiles, what we don't know is this side, but what we know is that 7 times something equals 42. So that something would have to be 6. 7 times 6 is 42. So Alexander and his grandfather are tiling their rectangular kitchen floor. They need to use 42 tiles. They're making rows of 7 tiles, so 6 rows, because 6 times 7 is 42. All right, good luck. Back to multiplication basic facts.